All right, here we go for 11.2 and 11.3. There's two parts for 11.2. We're going to start looking at 3D objects. All right, we're going to start off with prisms and cylinders and surface areas of those. All right, so a prism is a polyhedron, meaning it is a three-dimensional object, right? Meaning that it has volume, right? You can fill it up with water or sand or whatever, right? Um, and so, yeah, um, it has two congruent parallel bases. Two congruent parallel bases, right? And so look at these objects, right? Um, Here it looks like we shaded in the bases, right? A heptagon, a seven-sided figure, okay? This triangle we drew in the, I'm sorry, this prism here, right? We drew in the triangles because those are the parallel bases, right? So even though it looks like, it's laying on its side, quote unquote, right? If you were to tip it back up, right, the triangles would be the bases because those are the congruent sides, okay? And then for this box here, this third object, any pair of parallel faces would be the base, okay? And then here you have the pentagon, all right? Some more vocab here. You have to know what faces are. So you have the bases, and then all of the other sides are called lateral faces, okay? And they meet at lateral edges, okay? So lateral means side, okay? So these are the sides, all right? Altitude of a prism is perpendicular segment, so altitude creates 90-degree angle. It joins the planes of those bases, and the height is the length of the altitude. Okay. A prism may be a right prism, meaning 90 degrees, or oblique. Right? Think of it as slanted. If it's slanted, there can still be a height, right? Think of like a parallelogram. Remember, if this was the base, then the height is actually on the outside, like that. Okay. The lateral area is the sum of the areas of the lateral faces, and then the surface area is the total area, so that includes the top and the bottom bases. All right, so you're going to have to know those two. This actually would have been pretty neat if we did it in class. When you look at this hexagonal prism, if you were to cut the top and the bottom, right, and all of these lateral faces, the sides around it, actually unravel to a rectangle, right? And so the lateral area, which is LA, right, is actually the perimeter times the height, right? The perimeter is because if you add up all of these sides here, right, that represents these lengths here, right, in this hexagon, right? Those are the 6 sides here. And then you got to multiply by the height, right? So it's really kind of like a rectangle, okay? So that's the lateral area, the perimeter times the height. So here you're going to have these formulas given to you on the formula sheet. The lateral area for any prism is the perimeter times the height. And then the surface area is going to be the lateral area plus the area of the two bases. Now when you see this capital B, right, capital B represents the area of the base. And there's 2 of those bases, so that's why you have to multiply by 2. And so just a few examples to look at here, all right. You have the note solutions, but if you want to try some of these on the blank notes, you can certainly do that. So here, the lateral area for this triangular prism is, again, P times H. Perimeter of the base, right? So 5 plus 6 plus 5. So 5 plus 6 plus 5 times the height, 12, right? That's the height of this object if you were to stand it up. Okay, so the lateral area is 192 centimeters squared. Don't forget the units. And then the surface area would be the lateral area, 192, plus the two areas of the triangle, right? So now you have to incorporate the triangle formula, 1/2 base times height. Okay. In this one, again, pH for the lateral area. The 14 is one side, and so you find the perimeter around it times 20, right? So 14 times 6 because it's 14 times 6 sides, right? And then now we're incorporating, we did this last chapter, right? How do you find the area of a hexagon? And it's a regular hexagon. 1/2. This is AP is also the same thing as 1/2 ANS, right? 1/2 ANS. Okay, and so 1/2 times A. Remember that's the apothem, 12.1 in this case. N is the number of sides. Okay, and S represents the length of one side. Okay, so a lot of things going on at the same time, so you got to be careful here. Okay, I'm going to let you go over the cube on your own. And then a cylinder, right? A cylinder is a prism, but it's a circular prism, and so we call it a cylinder, right? Two congruent bases are circles, all right? And these are the same as before, altitude and the height, okay? For the lateral area of a cylinder, okay, the lateral area is, the idea is the same, P times height, right? The perimeter times the height. Well, but for a circle, the perimeter is actually given by the circumference. And so for the lateral area of a cylinder, it's going to be 2 pi r and then times h, right? So 2 pi r h. Okay, I would just use that, 2 pi r h. And then the surface area would include the area of the circles on the top and the bottom. So it's 2 pi r squared because you have two circles, 2 pi r squared, right? So again, a couple examples here. I think these are kind of straightforward. Okay, 2 pi r h, right? You have the r, you have the height. Notice here, you got to be careful with measurements. Okay, 1/2 foot, but the radius is given in inches. You always want to use smaller unit, and so 1/2 foot means it's 6 inches. So you got to make sure that you use the same unit. And again, capital B represents the area of the base. Okay. Sometimes you might have to figure out the height. I think that was the case here. It creates a 90-degree. This is a right triangle here. Okay. So you could either do the Pythagorean theorem, or if you recognize this is a 5, 12, 13 Pythagorean triple. All right. You can please go over this problem on your own. Okay. All right. I believe this is the second part of 11.2. Look at the blank notes. I felt like they were kind of repetitive from day one, and so I just wanted to highlight some more difficult problems here. So, you know, go to the note solutions on your own and look at the first part of day 2 of 11.2. All right. Here, wanted to go over, you know, the 4 right here where I'm highlighting. Okay, we found the lateral area. Okay, the perimeter times the height. And for the surface area, the area of the triangle is 1/2 base times height. So this 4 is congruent to this 4 here, right? So you gotta know that those are the same, right? And here we're just incorporating some more difficult objects. Okay, this is a trapezoid, right? So you gotta know the trapezoid area formula, or that'll be given to you as well. Okay, and also incorporating again 30, 60, 90 triangles, right? You gotta know these ratios. Okay, I think you're given the 4, which corresponds to this 4. If that's across from the 30, then you know the height is 4√3. Okay, and then the hypotenuse here is going to be 8. right? And again, incorporating the regular area. Okay, I know it says 1/2 AP. If you want to use 1/2 ANS, that's fine. I'll put a reminder in Google Classroom as well. So for 11.3, this is a typo here. I think it's supposed to say we're going to look at pyramid and cones. Okay, I think on the blank notes it says pyramids and cones. A pyramid is a polyhedron or a 3D object in which one face, which is the base, can be any polygon, and then the other lateral faces are triangles. So the lateral faces are always going to be triangles, right? Because they fold up in a sense and meet at a single point at the vertex. Okay. The altitude is the height from that vertex to the middle of the floor, if you will. Okay. Yeah. Hopefully you can discern and see what the altitude is here. All right. Again, altitude is perpendicular. Okay. The height is the length of the altitude. The slant height. Okay, this is key. All right. So if you look at this picture and where I'm highlighting, the height is, if you were to, like, let's say drop a rope at the opening of this pyramid straight down to the middle of the floor inside, right? The slant height would be the rope on the outside along the exterior of this pyramid. Okay, so there's a height and then the slant height. The slant height is always going to be perpendicular to the base. Okay, yeah, that's all. It creates 90 degrees. All right. Again, the lateral area is the same idea. Okay, it's the sum of the lateral faces, and then the surface area is the total, including the area of the base. Okay. Here's what it looks like. Right. The lateral area of a pyramid. Okay, it's really just the triangles, right? If we were to, the area of a triangle is 1/2 base times height. Well, the base is S, meaning one side length, right? And then the height is actually represented by the slant height when it's unfolded. So it's L, okay? And in this case, since there are 4 of them, because this is a 4-sided base, right? This is 4 times 1/2 SL, okay? And here, this is the formula we're going to use. The lateral area is actually 1/2 PL because where I'm highlighting 4S represents actually the perimeter, right? The perimeter of that base, okay? So 1/2 PL, and then the surface area is 1/2 PL plus B. Remember, capital B represents the area of the base. Okay, so please go over these examples here. All right, this hexagonal pyramid, this capital B, right? This is why we did the area of the regular polygon, all right, last unit. Okay, because you have to know how to find the area of this hexagon because that's your capital B. And then the lateral area is going to be from here, the area of those triangles. Okay, I skipped a couple examples here. A cone is pointed like a pyramid, but it's circular, obviously. You guys know what a cone is. A cone has a height, altitude, as well as a slant height, as well as a base. Here's the lateral area of a cone. It's pi RL, right? And then the surface area would be plus the area of the base, which is a circle, so pi R squared. Okay, so the surface area is pi RL plus pi R squared. Okay, in this example I want to highlight, sometimes you have to figure out the slant height, and in this case we have to use a Pythagorean theorem to do that. Okay, and then you know how to find the area of the circle. And in this one, there is no pi R squared for the circle because it's not on the surface. Alright, if you have questions, please shoot me an email, and I'm sorry to end on a rush.